Okay. Looks like my screen is now sharing. So, patterns and graphs. This is exactly what we are going to be looking at. So 2.1, can see there it talks about making sense of graphs that tell a story. So without wasting much of our time, I think it might be best for this lesson to just go through all this theory part, because all that we are going to do in the upcoming lessons will definitely be based on this very much important knowledge. So I'm just going to read through that first bullet over there, where we've got a statement which says a graph is a picture of the relationship between two quantities. Very, very much important, that part. To say we are actually looking at a relationship which is between two quantities. An example would be the distance and the time. So the advantage of a graph, the honorable member, is that what it does is that you can see the whole story at one time. That is the advantage of a graph. You can be able to see the whole story about the distance and time at one time. So now, very quickly, let's jump onto that second bullet where it says, this section gives you tools to analyze the information in the graph of a relationship. So the section gives you tools to analyze the information in the graph of a relationship. Okay, so this is what you will consider. Let's see. You will consider the following questions. Okay, you can see we are having things which ends up with some question marks. What's going on there? Okay, what does the graph look like? Straight line, smooth curve, broken line, separated points. These are some of the questions that you might be asking yourself. Definitely, you might also be asked such questions, and we will, as we continue, see how those questions are asked or how you should ask yourself the questions. So again, is the graph increasing or decreasing or staying the same? So that means a graph can do three of those things. Not only those, but lastly, does it change? Very, very much important, that part. Again, what quantity does the horizontal axis show? Normally, this would be the x-axis. So you might find a graph being like that. Normally, might find that being the time, or whatever the case may be. And then here, what quantity does the vertical axis show? So the vertical axis, normally, it is the y-axis, of which in that example, you might find that here we are having the distance. The distance can be in meters, millimeters, centimeters, kilometers, whatever the case may be. Just like with the time, the units can be seconds, the minutes, the hours, whatever the case may be, the honorable member. Remember that when it comes to the time, it can also be measured in days. Not only that, weeks, months, and even years. That is not the end. Can go on and on and on and on and on. Okay, then it's fine. Another question, where does the graph start on the vertical axis? Does it go through the origin? So that 0, 0, it's actually that point over there, where that line is 0 and also that line is 0. So that's why it's written like that as 0, 0. Normally that point is called the origin, being the starting origin. being the starting point. So does that graph start from there and does whatever that it does? Or perhaps does it start from there and do whatever that it does? Or maybe something like that, or like that. If it's dotted, it doesn't really matter that much, the honorable member. But that part of the question, it's what it is referring to. Does the graph change and where? Those are some of the questions, the honorable member, that you might be asking yourself or be asked. What is the highest point of the graph? In other words, what is the maximum point? Not only that, but the second question would be, what is the lowest point of the graph? In other words, we are talking about the minimum point. So let me just draw something there, and perhaps, okay, let me perhaps say that. Yes, something of that nature. Yes, no, it's not a perfect example, but just to give you an idea, we can almost say, let's see. So this would be the highest point or the maximum point. So whatever that value that we are having there, we will therefore know that, okay, that is the maximum point. Then in terms of the lowest point, definitely whatever value that we are having there, we will therefore say at this particular time, that's when we are having the lowest distance, something of that nature. But trust me when I say we are going to do some more problems with examples which make sense, unlike the one that I've just used there to explain. So as we continue, the honorable member, you might need to expect a situation where we try and make sense of all of this information that I've gone through. So for now, it was just a matter of me taking you through the theory part. And I think we might leave it there just before we get to some examples. Or perhaps, let's see, is there something that we can do here? Plotting points on a graph. Great. Okay, it looks like there's some information there that we can very quickly go through. Let me just see. An ordered pair gives us the exact position of a point on a grid. Yes, an ordered pair. So normally, this should be referring to the coordinates, where you've got a point that you can point on the x-axis and then another one on the y-axis. So that will give you the exact position on a point, the exact position of a point on a grid. So the first number in an ordered pair is the horizontal coordinate, and the second number is the vertical coordinate. Just like I've explained there, to say we've got the x-axis and the y-axis. So if you are having that, doesn't matter, it could be a grid like that. So this first value, it refers to whatever value along that line being the x-axis. And then this one, it refers to whatever value that you are having along that. So if, for example, let's say we are having 2 and 3, then we can count and say that being 1, that being 2, and then vertically 1, 2, 3. So you see that point, it is that one over there. That's what we mean when we say it gives you that exact position of the point on a grid. Okay, then it's fine. Let's see. So the order is very, very much important. Yes. So for example, if 5 apples cost 4 rands, then we could write an ordered pair like this, which means for 5 apples, it will cost you 4 rands. Then if you had to plot that, just like I did with 2, and 3. You'll firstly look for number 5, then it's 1, 2, 3, 4, 5, and somewhere there. So that means the x-axis represents the number of the apples, and then the vertical axis where you have 1, 2, 3, and then 4 somewhere there, and it ends up being where at a point where these two things meet. That is the point that you can mark on your grid. And here, obviously, this is the cost of the apple, obviously not in dollars, but in rents, just as it was given there to say for rent. Something of that nature, the honorable member. So perhaps the next information, it might be about having to plot that point. So let's see, what are they saying there? You start at the 0 point on the graph. That is the 0 point that we know by now. Move, let's see, move across the horizontal axis to the right until you reach 5 years, because we firstly have to start with that. Then move upwards until you are in the line with 4. Yes, exactly what we have done, the honorable member. Deal decisively with the x-axis, then you go for the y-axis. And from there, you can draw a dot or a cross where the line or the grid lines cross. And that way you have just plotted that point. Looks like exactly what I did, the honorable member. So the name of this graph, 5 apples cost 4 rand, plot the point. 5 apples cost 4 rands, plot the A. Okay, then it's fine. You've just plotted it there. Yes, I think we've just done all that they are trying to explain there. So the line that runs left to right is called the horizontal or the x-axis that we know by now. The line that runs top to bottom or bottom to top, it's called the vertical or the y-axis. The plural of axis is axis, pronounced as axis. Yes, something of that nature. So we've got an axis, which refers to either the x-axis or the y-axis. But two of them, we call them the axes. Hope you get that point, the honorable member. Not that pi, but that point. Okay, so I think we might as well leave it here and say until we meet again. I don't think I'm going to give you a test for this one because it was just the introduction to this. Okay, then it's fine. We'll leave it here.